All right, good evening, everybody. Thank you for being here on a Friday night. If you can't hear me, just let me know. For those of you who are in sections other than my own, welcome. I am Dr. Payne, otherwise known as D. Payne, and I just wanted to take the opportunity to provide a few more review materials before the second midterm. So again, let me know if there's a problem with the sound. Okay, so if you haven't already, on Learning Suite, your instructor may or may not have posted it. I posted my review materials under the day of the midterm. So we'll go through the review slides first to look at the conceptual section, and then do a flowchart example, and then look a little more closely at the HTML and CSS. So I'm not planning on going through an entire example, but I will point out some key components simply because I think the examples that you've had already are really good practice. There's just a few little things that we'll look at. So take the opportunity to get these materials. Oh, and the HTML and CSS are in a zip folder that will be similar to the type of folder that you have in the exam. So this time we're actually going to look at making sure that the files can connect to the other files in the system. Okay. Alright, so let me switch back over to the slides. Okay, so what did we talked about a lot of things. It seems like maybe we spent a year talking about HTML and CSS, but before that we did study security. And we took a look at this triangle, so of confidentiality, integrity, and availability, the CIA triad. Confidentiality being, making sure that you have limited access to information. Integrity, making sure that different parts of your data or information or your system can't be tampered with, can't be changed or modified. And then availability, making sure that only the people who should have access to the data do have access to that data. We also, and I'm going to try to keep pulling my email up here so I can see if anyone's sending me messages. So again, if you're not in my section, my email address is kcpayne@byu.edu if you have questions as well. Alright, so we discussed several types of identity theft and tried to scare you, you're at risk. So financial identity theft, simple example, when somebody steals your credit card and uses it to purchase things as you, they're not actually you. Medical identity theft, the case where you falsify medical records either for the purpose of getting better insurance or who knows what else. Criminal identity theft, so maybe you were going too fast on the highway and you got pulled over and you happen to have your uncle's or somebody's driver's license on hand for some reason, and you show the officer that ID. That would be criminal identity theft. And then, of course, child identity theft. Stealing the identity of a child is even possible, and it's a very terrible thing. Okay, so different types of authentication and authorization. Remember we watched the little clip from The Incredibles with Edna Mode, and she used actually 4 different types of authentication. Something the user knows, so like a password. Something the user has, like a key card, and then something the user is, biometrics, so retinal scan, fingerprints, things like that. So these are ways that you can authenticate, and then authorization, that's just making sure that users, the right users have the right access rights and privileges. Okay. Okay, so we talked a little bit about social engineering as one of the actual major threats to security. So these are very low-tech methods of gaining access to sensitive information, or, you know, I did the example in class of saying, yeah, I'm your professor, you know, can I borrow your laptop? And the students obviously said no, but I could try to gain your trust and take things from you. So more specifically, we also talked about phishing. So phishing is a type of email threat that comes in with the purpose of phishing for your personal information in the guise of either trying to make you afraid that something bad is going to happen to you if you don't do it, or that something good will happen to you if you decide to share that information. Okay, so we did talk about different ways of protecting yourself. I'm just going to highlight a few here, not go into all of them in detail. But we did talk about, let me just double check something real quick. Just want to make sure the stream, where did I put it? Ah, okay, there we go. And back to my email somewhere. Sorry. Okay, so firewall being just a means of making sure that network traffic that's not supposed to come to your computer, you know, doesn't come. Just the firewall's there to block unauthorized or suspicious content that might come through. So, and you can check this out on your own computer. You might have something like Windows Defender or another third-party program that is managing this for you. Okay, so some other things that you can do to protect yourself. You can use secured networks, so like BYU Secure, that requires a password to make sure that not just anybody can, you know, packet sniff and take a look at what you're typing. You can make sure that if you're doing transactions, you use websites that have the secure, so Hypertext Transfer Protocol secure method. But what you want to keep in mind is that even if you're, you know, using HTTPS, if somebody is sniffing packets, they're still going to be able to go ahead and see what it is that you're typing. So you need to have encrypted what you're doing. It's not just going to be a matter of using this protocol. So and then we talked about packet sniffing and saw an example. So just a case where somebody is able to use something like Wireshark or Ethereal to take a look at the content of the packets that you're sending. So if you're, for example, logging on to your online banking, they can see your username and password, or if you're, I think the example that Dr. Jenkins gave, typing a message over an instant messenger, you can see that message as well. Okay, so we also talked about different security threats, so including viruses, worms, and Trojan horses. So just a brief review of, you know, virus just attaches itself to legitimate files or applications and then spreads like a virus would spread, so replicates itself. A worm, the point of the worm is not necessarily to do anything other than just spread, so just to make as many copies of itself as it can and slow down your system. And then the Trojan horse, so the example from, what was it, the Iliad? What was the Aeneid? I don't remember. I think it was the Iliad. You know, something that it looks like you want to download, you want to click on, something that will be helpful to you. This disguises a legitimate program that is actually something harmful, so it comes onto your computer that way. There's a little bit of social engineering involved in that. Okay, we also looked at, let me draw the picture down. We looked at DDoS attacks, so distributed denial of service. What ends up happening here is we mentioned earlier that, you know, you might say, you know, why does a hacker why do they care about my computer? I'm just little old me. Well, because they can gather up a bunch of computers and turn them into zombies, so just computers to do their own bidding. And one of the things that they can do is assemble an army of zombies and have them ping a specific website. So everybody in the army tries to access the website at one time. And because of all that traffic, the website can't keep up with all of those requests, and then essentially is shut down. So that's why it's called denial of service. Okay, so questions about security? I'll pause for just one moment. I'm trying to think if there's anything else that is really kind of important. I think that's the majority of it. Sorry. Okay, I'll keep my eye out. But let's move on. All right, so next we spent a good portion of time talking about HTML. You guys worked through the Code Academy stuff and CSS, of course, so all those style sheets. Just want to say a few words about this before. So I think a lot of the HTML review do when we're actually working on the example, but just a few things to keep in mind. We talked about the different standards and the groups that set different standards. So the group that I think I mentioned in class defines the standards for HTML and HTML5, which is where we're at now. They're set by what's called the World Wide Web Consortium, so otherwise known as the W3C. And when working in HTML and CSS, when we were working on the websites that we were working on as a practice example, we were using the box model. I didn't specifically call out the box model, but I think you can understand it now that you've worked with it. So seeing where what a margin does, when we have margin or things like top, bottom, 20 pixels, etc., it's pushing it away from either the body itself or whichever element that it's nested in. So border, which if you assign a border to something, that'll go around the padding and the content. And then when we had padding, that just pushes the text or the elements inside of the element or box that you've created inward. And then, of course, you have the content itself. And so you can kind of think of it layered that way, if that helps. But we'll look at that a little bit more when we go through the example. Okay, and of course, if you have more questions about HTML or CSS, let me know. Okay, all right. So the last little bit, we talked about the systems development lifecycle and organizational IS, so how information systems works throughout all the functional areas in a business and the different tiers of information systems as they line up at the different levels of the business, from the executive down to the workers. And we did the airplane activity either last class or the class before if you're in the other sections. So everything from planning, figuring out sort of what's going on, the analysis, getting all of the requirements from the client, so about the airplane, design, actually drawing the airplane, development, so actually developing the software, the product, creating the airplane, testing, you flew them to see how well they matched up with the requirements that were defined in the analysis phase. And then we didn't do these last two phases, but again, implementation would be, if a company had a bunch of paper airplanes and you were going to implement your paper airplanes in place, how that would work. And then maintenance, just after they were installed and implemented, then maintaining them. And we mentioned that maintenance is a huge part of the SDLC, so it consumes a very large amount of resources, and some organizations spend 70% or more of their budget on system maintenance. So I would say it's the largest part of the cycle. So as we were working through the airplane activity, I forced you to not communicate down the line from the client onward. So essentially to simulate the waterfall approach. So where each of these phases just gets carried out one after the other. And so there's no client involvement until the very end, after the client has first talked to the analyst. So had a few groups complain about this, and basically they said, it'd be better if we could have constant client feedback, and so they're kind of getting at some agile methodologies. So there's different types of agile development, including RAD, so where you just do constant prototyping. You get the requirements from the client, you prototype that, and then check with them again and just repeat. Or some extreme programming and Scrum, where we just do mini waterfalls sort of on top of each other. But there's a lot of advantages of using an agile methodology over a waterfall methodology. Okay, so something that we didn't necessarily get to touch on, but goes hand in hand with the planning phase of the life cycle, is the feasibility assessment. So I mentioned it, and some of you probably experienced this when you were eyeballing the materials that I had on the table. You were thinking, okay, do we have the materials for it? You didn't have to do an economical analysis, but that would be, do the benefits exceed the costs? You may have done this in other business classes that you've had. Technical, so all technical is about is the technology available? So can we actually do this? Does the developer have the skills to put it together? So operational, this would be, once it's implemented, is it actually going to work? Is it going to work for your organization? Will you be able to actually use these planes? Do you have the capabilities of actually using them? Legal, is it legal, what you made? Does it meet all the laws? And then scheduling constraints. So, can you get everything done on time? Have you allowed time to do all the things that you need to do to get the job done? So, just another review of the implementation stage. So we mentioned 4 different types of conversion. You can just, plunge directly into the next set of paper airplanes, just change things overnight. You can do it in parallel, so just keep running the old system until you've got the new one up and working. You can phase things out, so sort of activate a new system one module at a time if it's broken up that way. And then pilot conversion, so you can test, maybe in one functional area of the organization how the new planes would work, and then see if you could apply it to other ones. Okay. And then as you were working on the project, I heard a few students say something along the lines of, well, we only have, X amount of time, we're going to have to cut some of this stuff that we have in the drawing. So what we're looking at is this this iron triangle, so these project management constraints of time, cost, and scope. And the triangle is a great way to look at it because as you adjust one of the sides, or two of the sides, the other side is going to have to be adjusted accordingly. And so it's just kind of important to think about how adjusting one or more of the constraints would affect one of the other constraints. Okay, so I think that is all I've got in terms of review of concepts. If you have questions, just let me know. And if not, I will start working on the flowchart problem. Okay. So, again, it's on Learning Suite. Okay. So I told my class this, but for those of you who don't know, I recently got some bunnies, and they're very cute, and I've been looking for an animal hospital that I can take them to, because essentially it's important to take a rabbit to the proper hospital, not just a hospital that deals with dogs and cats, because they don't often know how to deal with rabbits. So what I would like you to do is develop an algorithm and a program to help me choose an animal hospital for my new pet bunnies. So I have prepared a list of 7 potential hospitals that I have, and what I would like is the system to determine the quality, so Q, of each potential hospital by multiplying the number of rabbit specialists that are available there by the average online rating for the place, and then subtracting the distance that it is from my home. So let's see, did I do this correctly? Yeah, so I just wrote this a little while ago. I would like the hospital to meet a certain standard, so S, which is something that we'll define at the beginning. If the hospital being evaluated does not meet this standard, then the system should evaluate the next hospital. Okay, so let me finish reading it and then we'll break it down. So first, you're going to enter the standard that I would like the hospitals to exceed. So that would be S. Then the system should prompt you to enter some input variables, so the hospital name, the number of rabbit specialists at the hospital, R, its average online rating, O, and then the distance from home, D. So the system will then calculate the quality of the hospital based on these input values. It's going to calculate Q, and we want Q to be greater than S, right? So we've set a certain standard, and we want to exceed that standard. Okay, so the system will then calculate, did I say this? Yes, okay. However, here's one little thing. If the number of rabbit specialists R is less than 1, then the system simply moves on to the next hospital without generating any output. So if the standard is, and here's our termination condition, if the standard is exceeded for one of the hospitals, so if Q is greater than S, then the system should display the hospital name, the number of rabbit specialists that it has, and the calculated quality. Okay, so I've got 7 hospitals, and basically if all of them are cycled through, then the system should just say, well, no suitable hospitals are available, and maybe you should try another city. Okay, so we want to create a flowchart for the algorithm and then make sure that we have a legend. So I'm assuming that you have this sheet in front of you, so I'm going to pull it off screen so I can look at it over here. And also, where's my So yeah, so that is this flowchart example right here. Let me get this together. All right. And I'm going to work in the lucid chart, but remember that because it's in the testing center, you're going to need to draw it by hand. So I'd recommend drawing it by hand. Okay, so first thing we need is we need to start. So regardless of what we're doing, we need to start. Hope I have enough room for this. Let's see. Okay. So let's break this down a little bit. Actually, I'll pull this over here. Okay, so let's just take a look at the algorithm here and kind of work from there. Don't worry about so many of the variables. So it says first you will enter the standard that I would like the hospitals. Sorry, first you'll enter the standard that I would like the hospitals to exceed. So let's go ahead and do that. So we need an input, right? So we need input that looks like this guy, the parallelogram. And I'm just gonna do, so input, if your professor gave you different instructions as to how to do this, just follow that, but I'm just gonna simply type input S. Again, I apologize, what in the world is going on here? Okay. Alright, so the first thing we did, input S, let's connect that. Okay, okay, then the system will prompt you to enter a hospital name, etc., etc. So that's going to be an output, right? So outputs and inputs both use the parallelogram. So it's going to say something like, doesn't need to be that polite. So enter hospital name, number of, I have to make this bigger, specialists, average rating, and distance from home. Okay, so it's asking for that, and that's an output. So again, let's connect the flow here. Okay, so then the system will calculate the quality, so Q, of the hospital based on these inputs. So when we're it's calculating something, that's going to be a process. So Q is equal to, and then if you take a look up here, it says the system will determine the quality by multiplying, sorry, it won't let me do that, but by multiplying, I'm trying to point at my screen like you can see that, multiplying the number of rapid specialists R times the average online rating, and we don't need parentheses because order of operations will take care of that for us, and subtracting the distance from home. So we've got Q equals R times O minus D. And again, if it appears that I am making a mistake, please send me an email. It's definitely possible. But I think we're good so far. Okay, so we go through that process. All right. Okay, however, if the number of rapid specialists is less than 1, the system simply moves on. Okay, let's deal with that in a second. So I'm just going to keep reading. So if the standard is exceeded, let's go here. So if the standard is exceeded for one of the hospitals, the system should display the hospital name, the number of rapid specialists, and the calculated quality. Okay, so we need a decision, right? So we need to determine if the quality exceeded the standard. So the question is Q greater than is Q greater than S? And it's important, to notice that this is strictly, so I want it to exceed. I don't want to just meet the standard that I came up with. So some of this is going to change. So hopefully you're using pencil, but sorry about that. This is, I just think is the best way to work through it, at least in my head. Okay, so we have decision. So if the standard is exceeded, the system displays, so displays, that's output, the hospital name. So, oh, I didn't assign inputs, did I? Or did I? I guess that happens here. Just double check something. I think that's what we want. Enter hospital name. Let me just think about this for a second. I think we might have to assign the inputs there. Or do we? How can you... Yeah, okay. Good question. Yeah, that's what I need to double check real quick. Sorry, I kind of put this together recently. Give me 1 second. Okay, so we need, yeah, we need another input. Okay, all right. The question is, how can you have an input followed directly by an output? Yeah, all right, so let's, yeah, so obviously we need, are you asking about this part? So some things are going to change, so just hold on 1 second here. What we did forget to do, however, is we need to actually input the values here. So let's go ahead and do that. Okay, so that's not what I want. Yeah, we'll come back to this part. It's kind of saving that because that'll come with the iterations. Okay, so we need to input the, what is it? The name, the number of specialists, so R, the rating, and the distance. Okay, there we go. There we go. Okay, let's do that. All right. Okay, so then we calculate the quality, and then so I'm back here now. So if the standard is exceeded, we want to display the hospital name. So that's an input. So let's just do output. Hospital name, that's going to be in parentheses because it's an input originally. The number of rabbit specialists, which is also an input, so it gets put in parentheses. And then the calculated quality. Okay. So we've got that. Okay, so that's yes, right? If the quality is greater than. Otherwise, and this is where the iteration comes in, essentially we need to go back to the beginning, right? So we have to do the process over again. So, 1 second. Okay. So if no, what we want to do is, so you notice that you only have 7 hospitals to cycle through. So essentially what we need to do is have a counter that counts each time we do one up to 7 and then not exceed 7. So, but before we can do that, what we need to do is we need to define a counter. So I'm going to move this down. Okay, so at the beginning, we are going to, and I'll make a legend in a second, because that's an important part. I'm going to use I as an index, so, and go ahead and set it to 0, because when we start, we haven't done anything yet. So let's set that index to 0 right after we input the standard. And then, so essentially we only want to run this part if if I is less than 8, right? So after 7 runs, we don't want it to run anymore. Okay, so what we need is a decision that will determine how many, if the number of times, if it should keep going or not. Okay, so what we want it to do is ask whether or not the index, that's not what I want. The index is greater than or equal to 7. Right, so yeah, because if it's, is that correct? No, it's got to be less than or equal to 7. If it's less than or equal to 7, then it will run again. So we're going to have this be our yes down here. It doesn't actually matter which way you do it, you just have to make sure your yeses and nos are correct. Okay, so let me go ahead and connect this. Okay, so if I is less than or equal to 7, this is going to be yes, so it's going to run through again. Otherwise, we have another option. So we just have to kind of read and figure out what that option is. Okay, so, all right. Okay, so first of all, let's consider what happens if the quality that we had of the hospital was not up to standard. So it didn't exceed the standard. Essentially, we will get the right kind of connector here. If it's yes, we will make the output accordingly. If it is no, however, we want it to run again. Drag this out a little bit. Okay, yeah. So all I did here was if the quality was less than or equal to the standard, it's going to go back and check to see if it needs to iterate through it again. Okay. So, and we can go ahead and connect, oops, this here. Okay. So we're getting there. There's different pieces of this that we need to pick together. We just need to make sure we get everything that we need. So let's take a look at this last section. So if none of the hospitals exceeds the standard, so essentially you've run through all 7 that I gave, then the system should indicate that no suitable hospitals are available and suggest trying another city. So essentially we have a yes for this decision. Now we add a no. So no meaning that I is greater than 7 at this point. And then we have it, so we have another output. That will indicate no suitable hospitals available. Please try another city. Okay, and then I have to go back and do some more research. Let's change this guy. Okay. And at that point, so after we have, so we need to bring these conditions together, or I'm sorry, these outputs together. So because essentially the process ends once we've either found a suitable hospital or we've not found a suitable hospital. So what we want to do is after one of those conditions has been met, simply terminate. So let's see here. So we can have a flow connector here, and then simply connect like so, and then connect it to the end condition. Okay, so let's look at it again. We need to make sure that we have absolutely everything that we need, and I don't think we do at this point. So I wish I could get it. I'll zoom in again, but okay. So there's one other issue. If you reread it, essentially there's a catch where if the number of specialists is less than 1, the system simply moves on to the next hospital without generating any output. So it's putting in this kind of catch where it's going to sort of cut down on a little bit of the processing time. It won't actually have to run through the rest of it if there's no rabbit specialist there. There's no sense in even calculating the quality of the hospital because it's probably going to be too low anyway. So what we need to do is add another decision. Right, so we need to, let me zoom back in. So where's this decision going to go? So it's probably going to go right after we told it how many, the number of rabbit specialists, right? So right after we put in that input. So let me see if I can jimmy this around a little bit to add some stuff. Might get a little ugly for a second. That's not what I want. All right. Okay, so what we want is another decision point here where that's awfully large. Okay, we ask if is R is R greater than 0? So because we want there to be at least 1. So that will, there's different ways of approaching that. That seems like the simplest at the moment. And so we can connect this. If the number is greater than, if R is greater than 0, then yes, we want to continue with the processing. Let me scooch this over too. Okay. But if it is not, then we basically just want to return to, we want to go to the next one. So, and there's 2 other little things that we missed, which, if you're good, you'll have caught them already. Okay, so because, alright, so here's what we're going to do. Let me make this just bigger. Okay. So the purpose, if we run through, the thing essentially is not going to know how many we have counted unless we increase the index, right? So each time we iterate through one of these, we also have to increase the index so that it knows, what the current index is. So for example, here, when we were first doing this process, we should have also said something like I equals I plus 1. So because once we tell it that, it knows the second time around that now I is 1, now I is 2, etc., etc., until it counts up to 7. So in the case of this decision, what we need to do is essentially just bring it back up here, but on the way, since we've done an iteration, we also want to increase the index. So first we'll have another process in which we increase the index by 1, so I equals I plus 1. Okay, so if R is not greater than 0, then yeah, we go here. And then what we can do is separate this and add a flow connector. Another one. And join up those flows and have it continue along its iterative path here. So let's connect that and connect that. Oops. Okay. All right. So, do we have everything at this point? If you don't think we have everything at this point, send me an email. If not, I think we have everything. So, again, this is the good news is this is not part of the in-class portion. It's been pushed to the testing center portion, so you'll have plenty of time to go over your diagram and make sure that, you know, it covers the entire process. So that's the key. You need to just reread it, and make sure that, legend, thank you. Someone's on top of things. And make sure that it fits the process, and that you also have a legend. So let's go ahead and make a legend. Yeah, if you don't have a legend, that's going to be a problem, because the whole purpose of a flowchart is to be able to communicate with other people about the business process that you have. So without a legend, they won't know what you're doing. So let's see, what variables do we have? We have S, that's our standard. I don't like that it doesn't return for you. Okay, I, that's our index. So N, hospital name. R, number of rabbit specialists. Okay. I'll just leave it like that, because I'm afraid of what it's going to do here. O, so that's average online rating. Can space this out a bit more, there we go. And D, so distance from home. Give me 1 second to make this a little prettier. Okay, and wait, what happened here? Okay, distance from home. And what we got, the main thing we care about here, the quality that we calculated. So Q quality, is that all of the variables? I think that's all the variables. Okay, so make sure that you have your legend. Okay. All right. Is there anything else? Let me know. But yeah, so make sure you understand exactly how the process works, and you know, usually if you're going through something that requires a certain number of iterations, you're going to need a decision point where you decide whether or not your counter has reached a certain point. And while you're doing that, you also need to make sure that you're incrementing your counter, so, or your index. If you don't do that, then you know, it's just going to be, well, what would happen? It would just keep running and running and running, and never terminate. So we don't want that. All right. Okay, so that was flowchart example. Again, if you have other questions about that, let me know. Otherwise, I will move to looking at the HTML and CSS just to show you a couple of other things. Okay, so, and you know, you can take a screenshot of this if you want, that sort of thing. Okay, so the practice, you guys in my section have already seen this, but it's going to be a little bit different. So I'm just going to go ahead and download the zip file and open it as though I were, you know, in the actual testing situation. So let me go ahead and do that. Okay, so when you open it up, you'll see kind of how the file structure is laid out. So you've got the ELSA HTML page here, the CSS page here, a set of instructions, and then a folder for the ANA HTML page, and then a folder called Photos, which in this case I've actually made JPEGs of the photos instead of having URLs. So one of ANA and one of ELSA. Let's just change the file extension to make it. Yeah, okay. Alright. So you can see how it's laid out. So it's going to be important in the files to, because the way we did it, well, you'll see, it's not going to work exactly the way it should. Now, remember, if you want to take the exam in the lab, there's still some spots left. Please let me know. If you're working in the lab, what you'll have is the tool called brackets, so that I briefly demonstrated. That's what I'm going to use right now to just demonstrate a few things. So when you open it up, you see you can look at different files on the right and the left. So what I'm going to do is pull up the ELSA file over to the left, and then also drag the ANA file to the left. And then I'm going to go ahead and put the CSS file on the right. Okay. So, and I'm going to move my, well, I'll leave this here for now. We just, okay. So, at this point, though, what's cool about this, I don't know if they've updated it, but I know if you have Google Chrome that you can push this little button here, and oh, does it really? No, it was working for me before. 1 second. Yeah, okay. Make sure you're highlighted not on the CSS file because it won't be able to preview that. You'll see that it will bring up, if you're using Chrome, if you get some weird error, just, I don't know, let me know what it is. Let's see if I can debug it. But you can see the HTML based off of the style sheet that you had. Now, when we looked at this in class, you know, it looked a lot different, and that was because, well, if you see something like this, that's a red flag that your HTML is not properly linked to your style sheet. I mean, that's probably the first issue. So what I want to do is briefly, because this is about navigating the file system, I want to show you how to do that. So if you look in the folder, on the ELSA page, you know, to link to the CSS, it's quite easy because they're in the same directory. They're both just in this folder. So what I can do is go to where it has it linked, and again, you won't have to do this link part. It will be there for you. But what do I need to do here? So the name of the CSS file is style. So if I just change it to style and then save, you see that in my preview, all of the style is now there. So it just updated it automatically. Same with the ANA page. So you can see the ANA page is all messed up. But in this case, so the ANA page is in this folder here. So what I need to do to get to the CSS, so first of all, it's called style. Right, style.css. So if I just type style.css, that still doesn't fix it. You can see that. I need to navigate the file system. So essentially, the ANA file is in the ANA folder. I need to go up one level. So by using .. And brackets is very nice. If you do .. it goes ahead and kind of shows you some options. So I can then go to style CSS, then I don't need this, of course. So all I did was I went up one level, and then I was in the directory that I needed. I save that, and the page displays the way that it should. So according to the style sheet. Okay, so let's do one other thing here before I just review a couple other concepts. let's go ahead on the ELSA page and get rid of the link, so the URL to the photo. So in the image source, just delete that and save, and you'll see that that alt text appears. So just remember, the alt text is the alternate text that appears if the picture is not available. So what we want to do is, according to the file system, just get a hold of the ELSA JPEG. So to do that, we can, let's see, so we're on the ELSA page. So we just need to drill down into the photo, so it actually offers me that option. And then drill down into the ELSA folder, and then grab that JPEG, and there it is. So that worked pretty well. Yeah, so you see it doesn't have to be a URL. You can actually access the file. So you'll have to understand, if you're putting a photo on the page, exactly how to access it. Okay, so let's do the same thing for the Anna page. So delete the URL to the photo, and this time we're in this Anna folder. So what we need to do is go up one level. Where am I at here? So go up one level. We use // So // so I want to go into photos, and then Anna, and grab that JPEG. Oh, I didn't show you when it was broken, but you'll have to trust me that it wouldn't have worked if it wasn't there. I think you know that, though. Okay, so now all we've done is just switched the URL version of it to the actual saved JPEG. And let's see here. So a couple of other things that I just want to mention. Remember we mentioned this a few times, so it's probably drilled into your brain, but the heading here, this doctype HTML, is essentially letting it know that we're going to be using the HTML5 standard. So I just want to remind you of that. And remember that for pretty much every tag, you're going to need an opening and a closing, except in cases like, if you're putting a break in, so like I did here. So if I add another break, for example, I can just use BR, and it recognizes that as a break. So, so what are divs good for? So when we have a div, we want to do, usually one of two things. We want to break up the page into different sections, or we want to just have a specific section that is easily defined with different attributes in the style sheet. So kind of understanding what the purpose of that is. We talked about the differences between using an ID and using a class. So a class, for example, it's very easy just to make inline changes if we look at the ELSA page. For example, we had a class for underline, so we use the span tag when we're doing those inline changes. What else? So the other key, just to review one more time, was we talked a lot about this absolute positioning. Essentially, how it works, I'll just say this one more time. So if you specify absolute positioning for an element, like we did for Elsa's name here, so it shows it over here. So position absolute. What it's going to do is look for the nearest parent element that also has absolute positioning. So in this case, that's the header. And it will treat the margins and the padding, etc., according to the header then, because it is the nearest one that also has absolute positioning. So when I say, from the top, the margin should be 10. It's counting from the header, and from the left, 50 is also the header. So a lot of the what do I want to call them? The terms that you'll need, the keywords, will be available to you on the little sheet. It's not really a cheat sheet because it doesn't have everything on it, but it will at least give you an idea of what key terms are if you forget. And then just as a reminder, let me bring this back up. So here are some things you can do. So you can use brackets, Sublime Text, Notepad, or something similar. Just know what you see is what you get, editors. Yeah, you can use that standard note sheet, which I'll provide to you. And then you can use these two websites, so you can validate your code using the validator, and you can also use the W3 Schools as a reference. So, and again, so brackets lets you do this automatically. You can render your pages in a browser to check, and then of course it has to be HTML5 compliant. But there's been some concerns about, is a robot going to be grading my test? No. So the lovely TAs will be taking a look at that. So if you have concerns about that, let me know. Okay, so I'm going to pause for a moment here. So last time we went about 2 hours. I tried to keep this one a bit shorter. But I'll just sit here for a moment and see if you guys have any general questions, and maybe I can answer them before saying goodnight. Okay. Well, I wish... Whoop. Oh, okay, that's something else. I wish all of you, as well as the people who aren't in my section, the best of luck. Just come in calmly. I'll see if I can provide more Smarties. And again, if you're having issues with your computer, I still have space in the lab, so you can take it there. So thank you very much, and have a pleasant evening. If you have other questions, I'm still working through email, so just let me know and I'll get to those as soon as I can. Alright, have a nice evening, and I will post the YouTube video probably within an hour. It takes YouTube kind of a long time to render long videos, so thank you very much, and good night.